Alright, we're beginning your review for your integrals test and Riemann sum test, so let's get right into it. Finding the antiderivative, finding the integral. The antiderivative of x squared has got to be something x to the third power, and then what we need to do is then divide our previous coefficient by our new exponent. So it's 1 divided by 3, 1/3 x cubed, and we always need the plus c at the end. For number 2, the integral of 4x will be something x squared. It should be 2x squared. Again, we do that 4 divided by the new exponent of 2 gives me 2. Or I can just say, if I went and checked with my derivative, what would I have? 2 times 2 is 4 for x. And then for the 3 part, minus 3x, and always plus c at the end. For number 3, I'm going to first just rewrite this integral as the integral of 2x to the negative third power. And then I can take my integral using the power rules. I need to add 1 to my exponents. That means x to the negative second power, and divide my old coefficient by my new exponent. So 2 divided by negative 2 gives me a negative 1. So negative x to the negative 2 plus c. For number 4, the integral of cosine is sine, and the integral of sine is a minus cosine. So that's all you need for those two right there. And this last one, what I'm going to do is I'm first going to break it up into 2 different fractions. So what I'm going to first do is take this fraction and this fraction, make them into 2 separate ones. So that'll be the integral of 4 over x squared dx, and also the integral of x squared over x squared dx. Well, that's the same thing as saying the integral of 4x to the negative second power. And then this one is the same as saying, well, x squared over x squared is just 1 dx. And now I can go and evaluate these. This part will become, it'll be x to the negative first power now. And what I need to do is to have a negative 4 out front. Now I go back and check it here. Negative 1 times negative 4 gives me positive 4. Decrease my exponent by 1 gives me back negative 2. And then this part, the integral of 1 is just x, and then my plus c at the end. Even if you don't know how to do these, the plus c on your own is worth half credit for each one of these problems. Don't forget that plus c. That's important. Now, you don't need plus c for the indefinite integral because, well, you don't need to because we're evaluating it. So what we're going to do here first is to say, first we take the antiderivative, add 1 to the exponent, 3 halves. 3 halves times what gets me back to a coefficient of 1? That would be 2 over 3. I need to evaluate it from 0 to 9, which means I'm going to plug that in. 2/3 times 9 to the 3 halves power, and then subtract it by if I plugged in 0. Well, if I plug in 0, you'll see here, 0 to the 3 halves power. This is just 0. That part's just going to go away. This part goes away. So that's going to leave me with just this. 9 to the 3 halves power times 2/3. Well, 9 to the 3 halves power will be 9. We get 18 as our final answer. And you'd be able to plug this equation into your calculator to check your answer as well. For number 7, for this one here, integral of 3x squared will be x cubed. Evaluate that from 1 to 4. Means I'm just going to plug in 4 cubed and then subtract 1 cubed. And I get 63 for my answer on that one. 64 minus 1. Then this one, for number 8, I'm going to have x to the 4th will become now x to the 5th over 5. 1/5 x to the 5th. 2x becomes x squared. And I'm evaluating from negative 1 to 2. So I'm going to plug in first for 2. It'll be 1/5 times 2 to the 5th. Plus it'll be 2 squared. Then I'll subtract the other half when I plug in negative 1. So 1/5 of negative 1 to the 5th plus negative 1 squared. Now I'll just do my subtraction, plug everything in. This will be 32 over 5 plus 4. And I'll be subtracting off a negative 1/5. So that means I'm adding 1/5. And then I'll be subtracting 1 from that. And I'll use that in my calculator, or I can go and get my common denominator, whatever I need to do. And I will get a answer of 48 over 5, or I could put that in decimal. If you did it that way, it would be 9.6. on to the Riemann sums. So this is what we want to look at here. First, we're saying the integral from 1 to 10. So I want to go from 1 to 10. It doesn't say specifically how they want you to estimate it, but what we're going to do is I'll show you both ways you could have done it. You could have done either with a left endpoint with 4 intervals, 1, 2, 3, 4, or with a right endpoint with 4 intervals. So what we're going to do first, what is the width of each one of these? The width of this rectangle from 1 to 3, the width would be 2. Width from 3 to 4 is just 1. From 4 to 8 is 4. From 8 to 10 is 2. What is the height of each of those? Well, if I'm doing left endpoint, the height would be for this first rectangle, the left number, which is 4. For this rectangle, the left number is 12. The left number for the third one is 14, and then 12. To find the area of each one of these, I'm just going to go and multiply these. So 8, 12, because 2 times 4 is 8, 1 times 12 is 12. This here will become 56, 4 times 14 is 56, and this becomes 24. To find the total area, I'm adding all these up. So when I do, I get an area here of 112. So if I do the left endpoint, I should get 112 as my estimate. Now when I do the right endpoint, the way I'm going to do that one, I'll show you a little bit differently. Same thing, we're going to have the same intervals, which means we'll have the exact same widths. But now, instead of the left of the two numbers, I'm going to use the right of the two numbers. So, what that means my numbers are going to be here. I'll get rid of these guys. My new numbers now are going to be, this will be 12, because it's the right of this first box. This one is 14, it's the right of the second box. Then 12, then 9. So, my right endpoint will be 2 times 12 plus 1 times 14 plus 4 times 12 plus 2 times 9. And when I add all those up, I should get 104 for my answer. And I do apologize, I just realized that I wrote down the wrong answer for one of them. This last one, I should have had an answer of 100 even. That's my apologies. Not 112, but 100. Alright? So, that's how you do the Riemann sum. Now let's move on to another one where we have just an equation. We got to use this equation right here. We don't have a table. So what I'm going to say is make your own table. So we want 4 subintervals. So that means I want an x column and an f of x column. If I want to go from 0 to 8 and I need 4 subintervals, well, that means I got to be counting by 2s. This way I'm going to have 1, 2, 3, 4 intervals. What's f of x at each of these places? F of 0 is 0. Here's 4. Here would be 16 because it's x squared. This would be 36. This would be 64. Okay? What I want to look at now, the left endpoint Riemann sum. Well, left endpoint between 0 and 2 would be 0. And again, each of these gives me a width. In this case, each width is 2. So what I'm going to do, this left Riemann sum is going to be the width of 2 times the height. Left endpoint will be, of this first one will be 0. Plus a width of 2 times the height of 4. Plus a width of 2. This box right here has a height of 16. The last one, width of 2, height of this number, 36. When I add all those up, this is where I should have gotten 112 as my estimate. Now, to do the midpoint Riemann sum, we're using the same interval. So, when I do the midpoint, I'm going to start the same way. M of 4, I'm going to have 2 times some number, plus 2 times another number, plus 2 times a third number, plus 2 times a fourth number. Question is, though, we want midpoints. So we need the numbers in between. Well, what's that going to be? We're going to want the number 1, 3, 5, and 7 as the x values. So that means our y values here will be 1 squared is 1, 3 squared is 9, 5 squared is 25, and 7 squared is 49. These are our midpoints. So that's what I'm plugging in here. 1, 9, 25, and 49. So that means that my sum here in the end is 168 as that estimate. So that's how you do. Just make sure you pay attention whether it says left endpoint or the midpoint, or could have done the same with the right endpoint like we did in the one above. I keep my eye especially on doing that one. Alright, and the last one, using a calculator. All you have to do for these is literally just plug them in to your calculator. Plug it in just like it is. You're going to use that second calculate button. Then you're going to use, I think it's the 7th one that says integral fx dx. It says lower limit. You're going to plug in the lower number and hit enter. Then you'll plug in the upper number and hit enter. And it's going to come up with an answer. This one should tell you 68.199, and this one will be 29.219. Keep at least 2 or 3 digits after, because we know it's not precise at all. It's just a very good, it's an estimator, because we don't know how to take the integral of LL of x yet. We don't know how to do problems like this yet. We'll get there, but for now, it's just use your calculator to find it. There you have it. If you have questions on this, please email me, and we will make things all ready for tomorrow. Thanks a lot.